Okay, let's see about configuring IPSEC and especially seeing the behavior of BGP. So we did see like in the site-to-site VPN document, so this link will be shared in the description. So we have like the implementation aspect of site-to-site VPN and covered some points about various VGW features and how you can construct a VGW and what involves within integrating VGW with customer gateway and then like site-to-site VPN, and we finally ended up like installing and redirecting traffic within the VPC for IPSEC VPN. Now what we'll do in this particular scenario, it's just an extension to what we already built, right? So we are going to build dynamic routing. So dynamic routing works in a very specific way. So the entire setup remains the same, except for the fact on the VPN server we'll install FRR. It will be it's a routing suite, and there is a link which describes more about the implementation details of FRR. I'll like quickly go through how you can implement it. It's pretty straightforward, and we'll construct an IPSEC VPN tunnel in such a way that it uses tunnel 1 interface, and the BGP will be formed over 169.254 interface, which is by default allocated on the BGW end. So once we do that, then there is no need for the static routing configuration. Dynamically we'll see the prefixes will be exchanged, and from there on it's pretty straightforward. So few points. The VGW and FRR both support 2-byte and 4-byte ASNs. The range which we speak about here is pretty much the private AS numbers. The public ASNs are the ones which are in the internet. We use private AS systems, and the autonomous system by default Amazon would use is 64.512. So BGP peering will happen over 169.254 interface, and that's the default tunnel address that the BGW assigns. Now there is a misconception that BGP will probably happen over the public endpoints. That would never happen. Like once you need an IPSEC VPN tunnel or the session, and on top of it you'll run BGP. So your BGP packets or hellos are technically encrypted over IPSEC VPN, and IPSEC VPN is a pre-requirement to have this setup. If you're using the extending the strong swan use case, then what you have to probably remember is like you need to have a reference to the static configuration, because the dynamic version of it is not generated from the AWS console. In both the cases, for static and dynamic, VGW will still need the route propagation into the subnets. And the things which I have observed in this particular implementation is like the left and right subnets within the initial configuration phase needs to be default, otherwise the BGP messages are technically not being exchanged between strong swan and the BGW server, right? Now and within the strong swan there needs to be one change where by default we stopped at step 3, step 4 last time, and that was more than enough, and it was like doing an automatic route install. In this case we need to stop that, and then we have to configure everything to the tunnel. So let's start with configuring the FRR instance. So the way you can do that is pretty simple. So we are on IPSEC VPN server, and we can say sudo docker pull FRR routing /FRR. So this will pull the image which is required for FRR routing. So as a prerequisite, we'll first complete the FRR aspect of it, and then like we'll go to the IPSEC VPN configuration. So we'll say sudo docker run -t. So I want to run in privileged mode. Name is FRF1. Use host for routing and use image, the one which we just downloaded. So that should have spun up. Let's verify with docker ps, and we do see that it is up. So let's try to log into it. So IT is interactive terminal, for instance FRR1, and I need bash prompt. So we are in FRR and we need two requirements. One is, let's go to /etc/FRR and we'll say configure this file, and we need to manually enable which protocols we really want. So everything is set to default no. We'll go ahead and make BGP. You can also like configure OSPF and all the other protocols if you're interested for other use cases. And that's about it. This will also persist the reload configuration. So we'll say sudo docker restart FR1. So that's about it. So this completes the preliminary FRR configuration. We'll like come back when we have the tunnel configuration and everything ready. Now let's go back to AWS, and what we'll say is like we'll create a VPN connection. We'll say VPN over BGP. This is my virtual gateway. This is my customer ID. I require dynamic, and I'll say my left subnet is 0 and right subnet is 0. If you don't give this, then the problem what I have observed is like BGP is not getting established. So that created the configuration. Now what we have to do is like we'll not see OpenSwan listed in the downloaded configuration. That's not the case. So we'll go with the generic one, and we need the generic configuration just to know the secret key. So let me open it in Atom. S6. So let me get Atom. So we have the Atom configuration here. CD E6, this one, right? And we can see that this is the pre-shared key for tunnel 1. So let's go to IPsec secrets. Sudo vim IPsec secrets. Okay, and let's see the public IP. I think it should be there in the Atom file as well. So the public IP for tunnel 1. So that completes the secrets aspect. The one last thing that we have to do is like edit the configuration file. So this is the public IP address of the tunnel. So now that both of them are completed, we can say sudo IPSEC restart. And we can say sudo IPSEC status, and the tunnel is up, right? And we should be able to verify this here. So the tunnel is available, right? This status will still be down. You'll shortly see that the IPSEC of this particular tunnel will be coming up. The IPSEC will be up and the details would show that IPSEC is up, but the status will still remain down. The status will remain down till you have the BGP configuration configured up. So unless you go ahead and configure BGP, the tunnel status will technically be down, but the IPSEC would shortly be coming up. So there is one important aspect. I did say that you have to make sure that the default route configuration is not installed. So this is the config file that speak about. So if you see this particular one, there are a lot of configuration knobs that you can technically change. The one which we are interested in is the default installation. So where do we have this? Yeah, so this one. So install routes into a separate routing table for established IPSEC tunnel. So this is the default behavior. What we would say is we'll just bring it from the uncommented state and we'd say don't do that, so that everything comes onto the kernel. So we have the routing table state. So this is the routing table state, and let me delete the old configuration. So I have some old configuration, and what we'll do next is configure tunnel 1. So it's not much of a configuration involved in this case. So the first one will remain the same, except for you need to know the tunnel 1's public IP address, which we just edited in other details, right? So we'll say, yeah, this is what I was speaking about. So IPSEC is still up and the tunnel is available, but the overall status is down. That's because the BGP is still down. So let's configure the public IP address, and we would say this is the public IP, and the CIDR form is so this will be 81 because the AWS will have the first IP, and this will be 82 and the tunnel will be up. So basically what we are doing is we are trying to configure tunnel 1 outside IP address is referenced to the VPN VTI, and the inside is this address, and this address is the only address which the BGP will use. So let's configure it, and let's say if this came up, and our verification will be ICMP. If ICMP is not reachable, then you have to like revisit the configuration. For us it's just fine. Now since this is like technically this is done, let's go into Docker, and this is where we'll configure the BGP. Sudo docker exec it, which is interactive terminal for FR1, and take me to bash, and we'll say vtysh. So this is the actual Docker console, and within that it's emulating FRR. Show interface brief probably. So these are the interfaces, and it's directly like it gets connected to the tunnel. So what we'll do is we'll configure BGP. We'll say our in BGP is 65100, which is like which we have configured the BGP ASN while we were setting up the site-to-site VPN. And we'll say my neighbor is 169.254.185, and if you like reference it in the background, right, the first IP remote AS is by default AWS goes to 64.512, and that's about it. There is one configuration which definitely that needs to happen. So if you come back, so all of this would like still work. You need to like still have the next stop resolution via the default route, otherwise like you'll have problems. This is like FRR Docker will not be able to use the kernel's default routing table. So that's, we are just saying FRR like go ahead and use consult the on-box kernel for updates. So let's see the kernel, and we do see that the BGP is up now. Yeah, so you can see that. So by default, like different vendors behave differently, and FRR is no different. So for FRR to work, it needs some configuration for routes to get accepted or routes to get rejected. So we'll say route map. We'll say permit VGW. We'll say permit, and that's about it. So we'll reference this route map. We'll say neighbor, so and so. I think it should be an address boundary. Neighbor, so and so, route map in, route map permit VGW in and out, and we'll advertise our LAN network. So in this case our network is 192.168.1.0. so we'll say network, and if I say show IP BGP summary, I'm sending two prefixes and I have received one prefix, and if I see the prefix, you can see that I have received EC2 prefix, which is attached to VGW as a direct update to this particular router. Now let's go back to AWS, and if we go to the route tables, and if you select my VPC, so route propagation, as told you, like we have to propagate VGW, and route propagation should be S. And if I see the routes, we can now see that we have 192.168.1.0, which is advertised by BGP. So if you refer to the diagram, so this is the LAN gets advertised via BGP to VGW, and we can see this in the VPC route. So we do see that we have reachability. So this is completely addressed. The final verification is like, let's hop on to the EC2, which is on 10, and we should be able to reach this EC2, which is in 192 series. So let's go there. So we are in Frankfurt. We need one in Ireland. So let's go there. So these are my instances running. So this is my 10 IP address. So if I ping, so on this server, since there are tunnels and everything, what you need to do is like source the ping. So let's go here. We'll say 192.168.1.200, and we have the traffic. And at the same time, if we connect, we should be able to reach the VPN client, which has VPC forwarding. So let's verify that and we can close the session. It's taking a while, so let's try to connect it via SSH. So we'll say SSH -I VPN server open to, okay, so we'll say 192.168.1.101. so that's my VPN client, and I can reach the server as well. 1.200, that's my server. So now like we have proper IPSEC VPN and everything is exchanged via BGP. So in the next lab we'll have 2 BGP sessions coming on to VGW, and we'll try to like influence the path on with modifying various med and community attributes. Thank you so much.